Okay, so unfortunately OBS crashes every time I try to switch from one camera to the other, so I won't be able to do that intro that I was trying to, but we'll proceed anyway with just the top camera, and I'll try to talk over this. Let me just add a macro. Actually, this is a teleconverter, not quite macro, but it does get me closer to... Do I need to refocus? I think so. Let's see. Okay, I hope it's well enough in focus. So today on the workbench we got this Apocalypse car audio amplifier. I don't know if you can see it. ASA-1500.2. It is a 2-channel 1.5 kilowatt 12 volt car amplifier by Deaf Bounce, class D, mind you, with two completely separate amplifiers. As you can see, the symmetry through the middle. This is the power supply section, and obviously the main filter caps, the output of the power supply, and the chokes on the output, because it is indeed a class D amplifier. Wonderful class D amplifier, may I add. Unfortunately, it suffered the catastrophic short circuit on something. I'm guessing 12 volt on the signal ground, or something to do with the speaker. The plus 12 volt somehow got to the speaker terminals. Either of them would cause a major catastrophic failure like this, I guess. Either of these scenarios. And let's see if I can get this in focus and under light here. I think I'd have to bring it closer. We'll see. But this MOSFET has pieces of the neighboring MOSFETs kinetically shot and welded to it, even though the top on of the MOSFETs there were these hold down clamp heat sinks things. And as you can see, the missing part of this transistor is to be found it fell now, on the neighboring transistor. It's this part here that the cap packaging material, epoxy or whatever material it is. So what we're going to do today, these are the replacement MOSFETs for the power supply, and also a couple of MOSFETs in the output stage, and there are a few more bipolar transistors here that that are gone. I'm gonna replace those as well. Let's make some room here. Parts bin. And how do we work? I gotta get this out. The board. Carefully. Okay, insert that. Can I hold it like this? Can I get you out of the way? I'm thinking of laying it here. Awesome. Oh my god, if you could see this. The leg is melted. This is one of the MOSFET's legs, and it completely melted here. Dear Lord. This one's also exploded. I don't think any of them escaped. So we're gonna pull them all out. They're all the same part number. We're gonna pull the dead half of the output stage. Check for any other shorts. Then pull out the bipolar transistors. And if no other issues turn up, we're gonna try and power it up. I mean, what can go wrong? What could possibly go wrong? Worse than it already has, I mean. How can I pull these out? So there's this middle one. Add a dab of solder. And hopefully it will pull out cleanly. I'm just wiggling it. I'm not yet pulling until I'm sure the solder melted properly. Yeah. Dead as a doornail, a doorstop, or whatever. Where do I set these? I meant to put them in their box. Clearly that's gonna be needed. How should I best go about this? We got a parts can. Let's also extract this leg. Did it break on me? No. It didn't catch it right. this one has all of its legs still attached at least. Yeah, they're all missing parts of the package. I took a steel okay. Next on the line is that one. Is this one? It's not the only one. There's a couple of them here that still have their packaging hole. I mean, they're not blown to smithereens. Let's see these that are though. was quick. Should have took some pictures of the situation here. Perhaps for the next project, because my friend really wants this. Oh dear, it's falling apart. This one. Wants his amp back fixed, preferably. So we're gonna see if we can help it come back to life. Okay. These two seem... Could they have... Should I measure them? In circuit just for fun? I don't think I'm gonna leave them in, because even if they're not shorted, that doesn't mean they're okay. But let's see. Dead short. Oh no, it's a cap charging. But it is a dead short. From the gate to the drain. I'm looking at them backwards. Yeah, both of them. Shorted gate to drain. Yeah. What was I thinking? It's not like they've been saved by miracle. Let's pull them out. Because if they're indeed not shorted, that's the driving circuit. That's dead. And I don't think I got one of those. Haven't even looked what is the driving circuit. Could it be those bipolars there? I mean, it could be those. Therefore, and it's not like I'm gonna get a schematic for this, but let's see. Yeah, dead. Is there still a short in here? Nope. The board cleared out. And the last one, dead short. Let's get it out. out wherever you are. There we go. You're also gate to drain shorted, right? Yep. They're gate drain source, are they not? Okay, the power supply MOSFETs are out. We gotta clean this mess here. Should I get the output MOSFETs over here? It's this pair here, that's them, right? These other ones, that's good. I mean, at least not shorted. So there's a couple of them here. I want to know if there's something that would be preventing me from fixing it right now. I believe the output stage uses the same MOSFET between push and pull, but not the same MOSFETs as in the power supply, obviously, because they're different voltage and current ratings. Perhaps power also. We have a footprint for a larger package here. Nice. The ones that I got are identical to what was in here. And these were gate to source shorted, right? Yeah. And also drain. They're short. The output, half of the output stage is shorted all around. Are they in parallel by any chance? Did the short go away? It did? Okay, it seems like it did. I still wouldn't be trusting this, so we'll just get it out even though it's not shorted, this MOSFET. So only a quarter of the output stage MOSFETs are shorted, meaning 1 out of 4. Now, you gotta check this in the tester to see if it's still good. But perhaps after we fix it. What's this? Some IRS thing. Can't see. Gotta get my magnifying glass. Where did I leave that? be right back. Okay, let's see, what is this? IRF 6422 something. Is that all? IRFB 422 something. IRFB. Give it a wipe. 227. IRFB 4227. Is that what I got here? IRFB 4227. Yep. We got a couple of those, but this one might still be good. After the traumatic experience it went through, it's a miracle. Where should I set this aside? In there. Okay. How should I? Okay. Circuit is a bit burnt here. That resistor doesn't look too healthy. That resistor, all of these 4.7K resistors. And that one's good, perhaps, and this one, and so does that one. Let's see what they measure. So first one, that's looking good. It's 47 ohms. Yeah, 'cause it's 4700. 47 ohm precisely. 47.1. 47 precisely. 47.1, even though it looks a bit burnt. What? Oh, that is supposed to be a 470 ohm, and it's 469.0. We have another one here, 369.3.4, and now to the 47.1 ohms. 47.3. 47. I think they're all good. Last one, 47.1. So just this one was 47.1. Resistors are okay. How about these diodes? Diode mode there. 601 601 millivolt, 718. How about the other way around? Yeah, they seem good. The diodes are good, at least. How about on this side? Okay. 601, that's good also. And the last diode, 719. Let's try and clear out those holes now. Clean the tip. And let's start. First hole. Clear. Clear. Not clear. This has a larger ground plane or something here. It's stitched with vias around. Feel free to ask questions in the chat. It's clear. If you have any. If you just tuned in, we're trying to fix this neat looking Class D car audio stereo amplifier that is aptly named Apocalypse ASA-1500.2. I think that stands for 1.5 kilowatt 2 channel. Yeah, the third hole is always a stubborn one. First two can go quickly, but on the third I have to insist. Might have spoke too soon. Yeah, wait, I got my thing clogged up here. Yeah, that's what it gathered. My desoldering pump. Clear. I thought we pulled the trace, but it's okay. Excuse me, I don't think this little pump here can actually pull that hard. I'm afraid I must add some more solder to that hole. Where's my solder? That stubborn little hole. There. Yeah, cleared. Clear. Clear. something under it here. Not clear. Have to add some solder. Did it clear by adding solder? I think it did. Let's just blow on it one more time. Clear. Not clear. Clear. Awesome. What happened there? Oh my. All the holes cleared. Never mind. Oh, forgot to load. Clear. Should have left that more. Just add solder. And try again. Clear. Clear. That made it worse. My God. That's a stubborn hole. Just add some more. And try again. Don't work. Clear, fine. That took a while. Let's also also clear these from the amplifier stage. That's clear. That's also clear. Last one. Clear. Okay. Now let's clean up the mess here. Because we don't want to get any of this solder onto our board. That could be bad. Well, there's at least that. And now I gotta get to the ones in the middle. The small signal bipolar transistors that are here. I don't know if they're part of the driving circuit. Anyway, I think this module here is the power supply driver, or at least the controller part of it. These could be drivers. Maybe that's why they're blown up. Also, I have Is it still working? Because I shot a still. Nope. How about now? Huh. Yeah, there are a few parts here. Ah, shut up. I think we're gonna need this. I find a lot of tools very useful from the dentist toolkit and the surgeon. This is one of my favorite forceps, or what's it called. Yeah, let's check these holes. Okay. And that one's not quite all the way through. But I think the legs would make it. This one's bad. Can I see it here? I'm also warming up the needle. This is a dentist's needle. using to warm up and poke a hole through. Did I? I think I just lifted the trace on the other side. Oh, whoops. It can be fixed. Anything can be fixed. Okay. Okay, how about these? These are clearly cleared. Well, not so clearly. This one is not. Neither is this one properly. No, just one lifted trace. Not bad. But let's get to cleaning this here. Does it help if I turn on the bench light? Or is this too much light? I don't know how it comes on the camera, but to me it's pretty much the same. I'm just scraping off excess resin and then we'll dust it off. Gotta check that cap too. You never know. The board's a bit toast here. It got really hot really quickly. So remember, never touch the plus 12 volt from your car battery to the signal ground of your amplifier or to any of the output terminals, because it's doomed. It only takes a fraction of a second. Everything goes up in smoke. Like so. Also not liking this glue they used here. Other than that, it's really well built, this amplifier. The guys at Deaf Bounce definitely did a good job with this amp. Hope it sounds as good as it looks, because it looks great. Obviously the cap top capacitors that are used in the power supply here, these large electrolytics, are well, they're at least large. And also on the supply side here, these are on the plus 12. Plus 12 comes through these thick terminals. There's also these bus bars here going through, but there's a bit of bulk capacitance after the fuse, because there's a fuse here somewhere. Isn't there a fuse? Where's the fuse? Hello? Why have we no fuse? Why bother with fuses? I mean, what were they thinking? There's definitely not a fuse here. My God. No wonder it's so devastated. Yeah, there it is. DB. Deaf Bounce. These wires carry the output. These two are ground, and each one of these is a channel. So the grounds come in the middle, and the outputs are on the sides here. So this amplifier can be bridged. Does it already have a setting for that? Remote. I don't see anything to turn it into bridge. Mode. Crossover. Frequencies. Nothing about bridge. Picard to the bridge. Don't short out your amplifiers. They go kaboom. We also have a set of small signal transistors for it here. I think these are the ones that should work. I'm gonna need 4 PNP and 4 NPN. We'll start with the small ones in the middle, because why not? So there, 2SC3228 is what 4 of them are. 3228, 3228. I don't think I have to match their gains, right? Because they're just, you know, either driving the output MOSFETs or something. In the power supply, I don't think their gain actually matters all that much. This is coming apart. So here are 4. Let's get the other 4. Three. I'll change first one, I mean the PNP, and then the NPN, or something like that. Let's just get them out of there. One's already out because it was blown to smithereens, and the rest, anyone's guess if they're good or not, but I'll replace them all, just to be on the safe side. What is this? 1938, 2SA, 2SC, 2SC, 2SA, 2SA. I can get them all out because only the 4 in the middle are 2SA and the 4 outermost are 2SC. Let's see. Can I get them out from on top? Yep. Here's the first. Ouch. That's burning. I need to add solder. This is 2SA, right? And the outer ones are 2SC. Just making sure. You know, you can replace an NPN transistor with a PNP transistor. You just have to reverse collector and emitter, and obviously the polarity of the driving signal and the reference, and the main supply voltage plus and minus. You swap them around. It's a thing, trust me. I'd love to show you. I did that. I did it when I was young, and I sort of discovered on my own the quasi-complementary pair for the output stage. What did I pull here? The 2SC, right? $32.28. So I'll start with those. First these, and then these. I mean a couple of them. First a couple of these. There we go. I can't mess it up anymore. It's out. Now, let's clear out some holes. 1, 2, 3. It's like a waltz, you know, with these transistors. 1, 2, 3, 1, 2, 3. Let me unclog my pump. Continue. Oh, I don't remember their orientation. Ah, I think I do, actually. They were facing that way, right? Have to come back and check. But I believe they were all facing that way. I mean, facing that way. He went that way. That didn't clear. It did now. Just waltzing around here, clearing up some holes. I think my pump got clogged again. Yep, it did. Last one. Clear. So, what next? Next, we should dust this off. Because we definitely don't want any of that solder getting our way. Yeah, I think they're also marked on the board here. They're text in that direction. So they were a couple of these. 2SC3228. And then 4 of these. 2SA1275s. All 4 of them. I mean, they can't be anything else, right? Got on my glove. One glove, my brothers and sisters. So I say now I don't know how am I gonna solder these on camera, if I can or not. Should have gotten some of that hot snot something to hold them down until I soldered them. But yeah, never mind. Actually, let's separate them like so. Half on one side, half on the other. And perhaps we can tack one leg for each, like so. Let's see now. Tacky 1, tacky 2, three, and 4. Okay, that must have worked. 1, 2, 3, and 4. Oh, looking pretty good. Okay, we can flip this around now and tackle them on the other side. Oh my god, a forest of legs. So, how do we? Middle one. Outer one. soldering there. Okay. Then camera's off again. Oh, the battery's dying. And I'm in the middle of the forest here. Okay, that looks good. Like Mandit Mark does. Like his channel. Shout out if you're watching. I don't think you are. Just for the views. You can sing. And then so yeah, my live streaming setup isn't too great. I have me an analog HDMI switch. If you imagine such a thing can even exist. Whoa. Perhaps now one last final touch up. Make them nice and shiny. Yeah. And then I think we'll take a break. Let my battery charge on my camera, and we'll come back and replace the output transistors as well. I don't think the battery is gonna hold. It wouldn't take long. It shouldn't take long. The holes are already prepped. Nice. Where do we need to add solder? Everywhere, if you ask me. me. I really don't like this solder that they used. But other than that, I do recommend this amp for how well it's built. We'll see if it can be fixed, and if it can, how well does it also perform. Yeah, those are changed. Hopefully I set them the right way. I'll check in the camera footage. No shorts going on. Sometimes you get solder dripping through the hole and the leg of the component, and it messes into a big great blob on the other side. And I'm looking at something there. Here's where the... Nah, I don't think there's anything to worry about. Hopefully not. Let's take a closer look. Yeah, it's clear. Pirates of the Dark Waters. We'll see what happens shortly. Yeah, the output stage. Can I just put a couple in? Do I need to measure anything else here? Don't think so. I hate this packaging. But these are nice for CPU trays if you don't have any. They're also anti-static, so here's one, IRFB 4227. You go here, sir. And the other, we can open this CD box. Because any CPU would fit here, even those crazy large Xeons. Okay. These are some of the bipolars. Let's just temporarily put them here because they might not all be dead. battery's dead. Yeah, I'll come back to this after I get a chance to charge up my battery.